Today, we are going to build and test a laser security system using ESP32, OLED display, LDR sensor, laser module, and buzzer. This project detects any interruption in a laser beam and immediately activates an alarm while displaying an alert message on the OLED screen. Let's get started and see how this system works.
For this project, we use an ESP32 development board, OLED display, LDR sensor module, laser module, buzzer, breadboard, jumper wires, and a USB cable.
Before we begin the project, let's first make sure that our ESP32 board is working properly. Here, an LED is connected to GPIO32, also known as D32, through a 220 ohm resistor. The LED blink program has already been uploaded to the ESP32, so no additional programming is required at this stage. To perform the test, we simply power on the ESP32 board. Once power is supplied, the microcontroller starts executing the uploaded code automatically. As you can see, the LED connected to D32 is blinking continuously. The LED turns on for a short duration and then turns off repeatedly according to the programmed instructions.
Connect the 3.3 volts pin of the ESP32 to the positive rail of the breadboard. This supplies power to the connected modules. Connect the GND pin of the ESP32 to the negative rail of the breadboard. This provides a common ground connection for the entire circuit. Next, let's connect the laser module. The laser module generates a focused beam of light that will be directed toward the LDR sensor for intrusion detection. Now, connect the signal pin of the laser module to D5 of the ESP32. This connection allows the ESP32 to control the laser module and activate the laser beam for the security system. Next, connect the VCC pin of the laser module to the positive rail of the breadboard. This connection provides the power required for the laser module to operate and generate the laser beam. Now, connect the GND pin of the laser module to the negative rail of the breadboard. This connection completes the power circuit and allows the laser module to function properly. Next, let's connect the LDR sensor module. The LDR sensor detects the presence of the laser beam and helps identify any interruption. Connect the DO pin of the LDR sensor module to D34 of the ESP32. This connection allows the ESP32 to receive signals from the LDR sensor and monitor the laser beam continuously. Next, connect the GND pin of the LDR sensor module to the negative rail of the breadboard. This connection provides a common ground reference for the sensor and ensures accurate detection of the laser beam. Now, connect the VCC pin of the LDR sensor module to the positive rail of the breadboard. This connection supplies power to the LDR sensor, allowing it to detect changes in light intensity when the laser beam is blocked or interrupted. Next, let's connect the buzzer. The buzzer acts as an alarm and produces a sound whenever the laser beam is blocked, helping to alert users about an intrusion or security breach. Connect the negative terminal of the buzzer to the negative rail of the breadboard. This provides the ground connection required for the buzzer to function properly. Now, connect the positive terminal of the buzzer to a terminal strip on the breadboard. This connection allows the buzzer to receive signals from the ESP32 and generate an alarm sound when an intrusion is detected. Next, connect a jumper wire from the ESP32 D8 pin to the same terminal strip where the positive terminal of the buzzer is connected. This allows the ESP32 to control the buzzer and activate the alarm when the laser beam is interrupted. Next, let's connect the OLED display. The OLED display is used to show the current status of the laser security system and intrusion alerts. Connect the SDA pin of the OLED display to D21 of the ESP32. This connection enables data communication between the OLED display and the ESP32. Next, connect the SCL pin of the OLED display to D22 of the ESP32. This connection provides the clock signal required for communication between the OLED display and the ESP32. Next, connect the GND pin of the OLED display to the negative rail of the breadboard. This connection provides a common ground reference and ensures proper communication between the OLED display and the ESP32. Finally, connect the VCC pin of the OLED display to the positive rail of the breadboard. This supplies power to the OLED display. Now that all the connections are complete, power the ESP32 using a USB cable. As you can see, the laser beam is continuously falling on the LDR sensor. When the beam is interrupted, the ESP32 immediately detects the intrusion, activates the buzzer alarm, and displays an alert message on the OLED screen. Here is the complete circuit diagram of the laser security system. It clearly shows the connections between the ESP32, laser module, LDR sensor, buzzer, and OLED display, making the project easy to understand, build, and troubleshoot. This completes our laser security system project using ESP32, OLED display, LDR sensor, laser module, and buzzer. The system successfully detects interruptions in the laser beam and provides both visual and audible security alerts. Thank you for watching. If you enjoyed this project, please like, share, and subscribe to the channel for more electronics, IoT, and robotics projects. See you in the next video.